Okay, so if I recall correctly, the first assignment is due today, and we'll take it up tomorrow. So at the very least, it has to be up. It has to be submitted by tomorrow, by the beginning of class. So everyone, please take note of that. I've also posted the second assignment, and once we finish chapter 2, which I think will be today, we'll decide on the due date for that. I think that'll just be, again, just due next Wednesday, and then we'll take it up Thursday. I think that seems like a logical route to go. So everyone, let me know if you have any questions about the first assignment or the second assignment, since it is up.
How are we submitting it?
Just on Dropbox. So
Okay,
everyone just take a picture of your assignment or scan it if you have a scanner and just submit it on Dropbox, just as long as it's legible, readable. Any other questions? So everyone seems good. Okay, let's share screen. So we're going to skip multiplying and dividing fractions because calculators exist, and I'm not quite sure why it's even in the course outline. So goodbye to long division. I'm sure no one will be overly upset. So we're going to skip to Introduction to Percentage, and this will conclude chapter 2. And then when we have the first test, it'll be on chapter 1 and chapter 2. So it'll be on fractions, decimals, and percent. So I'm still recording, good. Okay. And this lesson it's fairly straightforward, so not too stressful. Even Buddy will be okay. Okay. Okay, so, and then also just to clarify, tomorrow we'll still be doing an online lesson. I originally wasn't going to do that, but then I realized if I spread my cold to other people, they have no way of knowing if it's COVID or if it's cold, and I just didn't want to waste hospital resources on useless tests. So I'm just playing it safe this week, but the week after will continue as per normal. Okay. Percent comes from the Latin per centum, meaning by the 100. So the word percent means out of 100. It always means that. So most people generally understand what percent means. Like if you get 75% on a test, most people realize that that means they got the equivalent of 75 out of 100 on their test, even if their test wasn't literally out of 100. So percent is basically a way of standardizing numbers and scores so that it's automatically out of 100. So any number written as percent means that many parts per 100 part. So understanding percent is pretty important. I teach it. I think I could say I literally teach it in every class. Yeah. I don't teach it in calculus, but that's because it kind of goes without saying in such an advanced class. So here are just a couple of basic illustrations from, quote, mathisfun.com, end quote. 25% means 25 parts per 100. So here's just a basic illustration of that. And then of course, 50% means half. It means 50 out of 100. And then of course, 100% means all. It means 100 out of 100. So in that case, you have all of your little green blocks filled out. Okay, so now we're going to learn how to convert between fractions and decimals, between decimals and percents, various things like that. It ends up being pretty straightforward because, again, percent means out of 100. So whenever you're dealing with percent, as long as you remember that it's out of 100, you could usually remember how to convert between the various types of numbers. So in this case, we're going to start with converting from percents to fractions, which is definitely the most easy type of converting. Okay, so let's do this. So we got 5%. And what you do is you drop the percentage sign and you just write the number over 100, which makes logical sense because 5% means 5 per 100. So the answer is literally just 5 out of 100. So that's how you convert from percentages to fractions. All you have to do is just remove the percentage sign and put the number over 100, and that's it. So 33% is equal to 33 over 100. And then the last one is 175%. And that, not surprisingly, is just 175 over 100. So the general rule for this is you drop the percentage sign and you just put the number over 100. But there's still a lot of mistakes that people make in this case. For example, for the 5 over 100 example, a lot of people will write 5% over 100, but you can't do that. If you're going to put it over 100, you have to remove the percentage sign. So there's technically 2 steps to this process. Get rid of the percentage sign, goodbye percentage sign, and just write the actual number over 100. So make sure you don't make that mistake. But aside from that, that's all you have to remember, at least for converting from percentages to fractions. So let's do some examples. We'll just go through these quickly since there's not really much further to say about them. 7% is 7 over 100. 45% is 45 over 100. 98% is 98 over 100. Hopefully everyone is starting to see the pattern here. And then 150% is still just 150 over 100. Some people find it, I guess, I don't know what the word is. Some people don't like percentages that are higher than 100%, but it does still make logical sense. For example, you could get bonus marks on a test and you can get higher than 100%. So despite the fact that it's out of 100%, you could still have percentages that are higher. For example, in this case, 150% is 150 out of 100. So that's all the answers right there. And yeah, I literally can't think of anything else to say about that. You don't have to reduce these because we've already kind of separately discussed that. And a lot of them are, there just doesn't seem much point to reducing these because they're all out of 100 anyways. So you don't have to worry about reducing them. Okay, next one is converting from a percent to a decimal. This is technically the exact same process. You're just taking a number and dividing it by 100. You're just doing it a little bit differently in this case. Rather than literally writing it over 100, you're just going to take the decimal and move it twice to the left, which is the same as dividing it by 100. Because remember, our decimal system goes tenths, hundredths. So if you move a decimal twice to the left, it's the same as dividing it by 100. So in this case, we're converting from percentage to decimals, but it's the same logic as converting from percentage to fractions. So let's do a couple of these. 5%. 5%. So if you can't see the decimal, it's always just at the right end of the number. It's right here. So you move it over once, twice, and there's your decimal. You got a 0 there, and you got a 0 there. So 0.05, which if you're looking at this from a decimal point of view, actually makes sense. Because remember, 0.05, the 5 is in the, quote, hundredths category. So it's 5 hundredths. In other words, 5 out of 100, which is literally 5%. So it makes sense in this case to take the decimal and move it twice to the right. Always try to, whatever topic you're doing, always try to confirm it using like some type of separate logic or something like that. That's what I like to do. What do you think, buddy? Buddy's excellent. Okay, so let's do 33%. So again, the decimal's right here. and you just move it over once, twice, and that's it. So it's 0.33. You always move it over twice. It doesn't matter what the number is, doesn't matter if it's a large number or a decimal, twice is always what you move it over. Because again, tenths, hundredths, and percent means per 100. So with percentages, you could get away with just remembering that it means that it's out of 100. And if you remember that, you could pretty much logically deduce pretty much everything about percentages in regard to converting them. Here's another one, 175%. So here's the decimal right here. And again, just move it over twice. Once, twice, and you get 1.75, which makes sense because 100% would just be 1. So 175% is a little more than 1. It's 1.75. So it's always just twice. And the reason I clarify that is because people don't listen when I say that. They move it over once, they move it over 3 times, they move it over 5 times, just move it over twice. That's all you have to do. Doesn't matter what the number is. Yeah, so just remember that. So let's do a couple of these. Okay, decimal is right here. So once, twice, here's the decimal. You got a 0 here and a 0 here. So 0.07, which literally means 7 hundredths. So again, it makes sense that that's the equivalent of 7%. Let's do 45%. Here is 45%. Here is our decimal point. Once, twice, and you get 0.45. So again, it's always twice, but for some reason, people just don't listen to that. They always move it once or 3 times. And in some cases, I can understand why. Because in some cases, it seems like you should get a particular answer or an answer of some kind. But as long as you move it twice, you'll get the right answer. So 98%, 98. Here's the decimal right here. Once, twice, 0.98, which again means 98 hundredths. So it makes sense that that's 98%. And then 150%, let's write that down. Here's the decimal, once right there, twice right there, and you end up 1.50, or you could just write 1.5. So in this case, when you move over the decimal, the only thing you really have to remember is just to remove the percentage sign, and that's it. So remove the sign, move the decimal, and everything is good. What else can I say about that? I guess there's not much else. Let's see what else there is. So here are the answers. Ooh, this is another interesting one. This is a chart. I think I got this from one of my business textbooks, but it was a good chart because it has a lot of different examples. So let's just go to a whiteboard. Otherwise, I don't really have room.
Isn't technically it the rule of like if you're converting it from a decimal to a fraction, it's like times 100. If you're converting it from a decimal or from percent, you divide by 100 technically?
Yes, you're correct. If you, here, let me go back to the slide for a second. Share screen, this one right here. Yeah, so if you're converting from a percent to a decimal, technically you're dividing by 100. But if you're going in the opposite direction and you're converting from a standard decimal to percent, then you're multiplying by 100. So you're absolutely right. It just depends on what direction you're going in. But we'll definitely cover that in a couple minutes, going in the opposite direction. But it's either dividing by 100 or multiplying by 100. So at least in that regard, it's fairly easy to remember. Okay, let's go to a whiteboard. Come on, whiteboard, work. whiteboard. Here we are. Okay, sorry. I literally just woke up. Apologies. Okay, so this is a chart in the slide. Like I said, it's just from another class, but it's a good chart. It has some more challenging questions. So we'll go through all of them, including the more basic ones. So it gives you a percent and asks you to convert to a fraction, and then it asks you to convert to a decimal. So the first one is just 17%. So let me do some headings here. So fractions for F, let's do D for decimal, just so we know what the heck's going on. So for a fraction, it's just 17 out of 100. That's all you do for that. And then for a decimal, just take the decimal place and move it over once and twice, and you get 0.17. So that's what you do just for that one. That's the most basic example. The next one is a little bit different and more difficult. You actually have 0.8%. So this one's interesting because it's a decimal mixed with a percent. It's 0.8, it's a little less than 1%. So it's pretty low. Like if you got less than 1% on a test, you'd probably be a bit perturbed or a bit annoyed. So it's a very small number. But the process of converting it to a fraction or decimal is exactly the same. So for converting it to a fraction, you literally just take the number, which is 0.8, and just write it over 100. But at this point you run, so that's correct, it's perfectly fine, but at this point you run into a tiny problem. You don't want to mix decimals with fractions because it just looks ugly, and it also kind of defeats the purpose of having decimals and fractions. So what we'd like to do is just adjust this one a little bit. Does anyone have any suggestions for how we would adjust it so that it only has whole numbers in it?
Round it up to 1.
Someone said round it, but that's a good suggestion. But by rounding it, we're going to lose some accuracy. What I would do in this case is, since we have 0.8,
Make it out of 1,000.
Oh, go ahead.
Make it out of 1,000 instead.
Exactly, yes. Someone said make it out of 1,000. So what we're going to do is just take the top and multiply it by 10, because that'll convert it to just a whole number. But if you recall, when we do something to the top of a fraction, we have to do the same thing to the bottom of the fraction. So what we can do is just multiply the top and the bottom by 10. So that'll keep it the same as what it was, but at least in this case, we're getting rid of this ugly decimal that we have. So the top will just be 8, and the bottom will be 1,000. So a lot of that's typically what you do when you have a decimal mixed with a fraction. The easiest thing is just to multiply it by a factor of 10, and then do the same thing on the top or the bottom. And then you get a consistent answer and a correct answer. What else did it want? Oh, right, it wanted to convert it to a decimal. So let's do that. So here's the original percent, 0.8%. So just move the decimal twice to the left. Once, twice, here's our decimal, here's a 0, and here's just the 0 on the left end. So you get 0.008. It's a really small answer, but it actually makes sense because our original answer, 0.8%, is also a really, really small number. Again, if you got it on a test, it would be a big fail. So again, just move it over twice. It doesn't matter if it's a large number. It doesn't matter if it's a decimal. Twice is always the way to go. For some reason, in this case, when people get like a decimal percentage that they're trying to convert to a pure decimal, they'll move it over once, they'll move it over 5 times, they'll move it over 3 times. Just move it over twice. That's it. That's all you have to do. What else? The next one I'm going to skip because that one's pretty easy. Let's go to 215%. So for converting it to a fraction, just put it over 100. 215 over 100. And like I said, don't bother reducing it because it doesn't really matter. That's not really the point of these questions. So you could just keep it like that. And then for converting it to a decimal, you have 215%. Your decimal is right here. Move it once, move it twice, and it lands right there, 2.15. And again, if you're going to move it twice to the left, just remember to remove the actual percentage sign, because if you keep it there, it's not technically correct. What else? There's another one. I'm just going to clear this, but keep in mind this is all in the PowerPoint. The next one is kind of similar to one we previously did, 0.75%. So again, a really, really low number, less than 1%. So if you got this on a test, you would definitely have failed miserably. So it's a very low number. The reason I point that out is just if you get a low number as an answer, don't panic. It's still perfectly correct. So let's just do the fraction part. So just take the number 0.75 and put it over 100. Now, of course, we run into a similar problem as we did previously. We don't want to have a decimal within a fraction. So in this case, you just multiply it by any factor of 10 that will get the top to be a whole number. In this case, we'd like to multiply it by 100 because then that would move the decimal over twice and you would just get 75. But as per usual, whatever you do to the top, you have to do it to the bottom as well. I think that's basically the #1 fundamental rule in math in general, is that you want to keep everything equal and balanced. So the top is just going to be 75. And the bottom, so we got 1 0, 2 zeros, 3 zeros, 4 zeros. So 1, 2, 3, 4 zeros, 10,000. So 75 over 10,000. I find that the easiest way to do it. Just count the zeros and use that number of zeros so that you don't make any mistakes. So 75 over 10,000 is perfectly correct for this one. And then the last thing for this one is converting it to a decimal. So 0.75%, here's the decimal. Move it over once, there it is, and move it over twice, and there it is. And then you get a 0 here and a 0 here. And then you get rid of the percentage sign. So 0.0075. Again, the original percentage was a really small percentage. So this answer is actually reasonable. But this is the type of answer that just for some reason, everyone gets it wrong. Like they'll move it over twice to the right, or 3 times to the right, or 3 times to the left, or once to the left. They'll basically do anything except just moving it twice to the left. And it's understandable because I guess when they see this answer, for some reason they think that it's incorrect, but it's not. It's perfectly fine. Again, just move it twice to the left. So what else is there? Are there any other ones? Oh, this is an interesting one. 3 over 8%. So we haven't really seen that before. That's a fraction mixed with a percent. So in this case, what I would do is I would just take the 3 over 8 part and just convert that to a decimal initially. And then it's a bit easier to solve from there. So just convert the actual 3 over 8 part. 3 divided by 8 is 0.375%. I'm still keeping the percentage sign because we haven't actually converted anything. All we did was convert from a fraction to a decimal. We haven't actually converted from a decimal to a percent or anything like that. So this is what we have initially. And now let's do the fraction part. So again, just do 0.375 over 100. And again, as per usual, it looks really ugly. It's not really a proper way of doing it. You want to get rid of the decimal part. So what you'd like to do is move this over once, twice, 3 times, which is the same thing as multiplying it by 1,000. But again, you got to do the same thing on the bottom, just to keep everything balanced. So this is 375. Ow, sorry, my dragon is scratching me. And how many zeros? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So that is 375 out of 100,000, which is a perfectly good answer because the original one is really, really small. It's only 3/8 and it's a percent. So again, it's less than 1%. It's actually it's even less than 0.5%. What else do we need to do for this one? Oh, right, converting it to a decimal. So let's just take this version right here, 0.375, and let's convert it to a decimal. So surprise, surprise, all you do is move it over once, twice, and that's all you do. So 0.00375. And that's the answer for that one. So with percentages, the nice thing is that if you remember that it's out of 100, you can practically deduce literally everything about how to solve and convert percentages, as long as you remember that it's out of 100 and therefore you're moving the decimal twice in whichever direction. In this case, going from percentage to decimal, moving it twice to the left, because our decimal system goes tenths, hundredths, and it's always associated with hundredths. Okay, what else do we have? So now we're going to convert in the other direction. So instead of converting from percentages to decimals, we're going to go from decimals to percentages. And it's pretty easy to guess the method for this. It's the same method, but since we're converting in the other direction, we just move the decimal in the other direction. So let's just do some of these on a whiteboard. Okay, so let's convert 0.13 to a percentage. So in this case, going from decimals to percent, you just move the decimal over twice to the right. So once, twice, there you go, and you just get 13%. Which makes sense because 13 by definition, according to our decimal system, is 13 hundredths, which is 13 out of 100. And 13% literally means 13 out of 100. So everything always, in math, believe it or not, everything always makes sense. If you really think about it. I know many people will disagree with me, but in math, at least everything kind of comes full circle. Another one is 0.65. So again, you just move it over once, twice. Here's the decimal right here, and you just get 65%. What else? 1.04. Surprise, surprise, you just move it over twice to the right. Again, once, twice, and you get 104%. And that makes sense because 1 is 100%, right? Because 100% is 1 whole. So 1.04, you should expect your answer just to be a little above 100%. What else? Geez, this is going by fast. It's already 5:04. Oh, and just a reminder, again, tomorrow I'll be doing an online lesson. I'm not concerned about getting people sick, but like I mentioned in my email, if I do get someone sick, they have no way of knowing if they have COVID or a cold, and I just don't want to waste resources and COVID tests. That's why I decided just to do this week online. And to be honest, I had no car. So it was like 2 birds with 1 stone. I sold my car, thank goodness. Selling a car is so stressful. Oh, geez. Never get a car just in case you have to sell it, because you will lose your mind. So many people will try to scam you. I realize I shouldn't complain, but yeah, selling a car is just atrocious.
Isn't it better to
So
just try to sell it to the dealership?
yeah, we were gonna, that was our last resort. Yeah, but it was like a pretty good car, and to the dealership, you'd get like 300. Luckily, we
they'll
got
scam-
a little more than that. Yeah.
They'll scam you too, the dealerships. Just
What's
like
that?
people. I said they'll scam you too, the dealerships.
Exactly, yeah. So we found a
Because the
person
dealerships still
who,
need to sell the car.
what's that?
The dealerships still need to sell a car, so you're gonna get less for it because they need to make money, right?
To be honest, I think they were just gonna scrap it for like metal and spare parts. That's how old my car is. But luckily we sold it to a person who could kind of, who needed an old car just for driving around town. But like, oh man, I don't like to complain, but apparently this was in my brain because it came out. But like, so horrible. Oh, I never want a car again, just in case I have to sell it, because it was just so stressful. Like yeah, it took like 3 weeks talking to Kijiji, or people on Kijiji every day. And then you have people trying to scam you. And it's so obvious that they're trying to scam you. It's like, hey, I want your car. I'll give you a $5,000 deposit. Just go to this sketchy website. No worries. And it's like, how about no? How about I don't do that? So yeah, I don't know how I got in this car rant, but I appreciate everyone for listening, because it was just, I was so stressed about it, to be honest. Okay. So what were we doing? It was, oh, we got a chat. Oh, did I already take attendance? Yes, I take it in the beginning and at the end, just so I try to cover everyone. And if anyone is listening with you on your laptop, just let me know and I'll mark them as present as well. Okay, so it was, oh, another chat. Oh, someone said they were 5 minutes late. Let me just, here, just so I don't forget, I will mark them as present. I need a real pen. Here it is. Let's see. This person, there we go. Present. Where's Buddy? Oh, he's hiding in my hood. Okay, you hang out in my hood. Okay, so this is just a bunch of examples of converting from decimals to percents. And again, just move the decimal twice to the right. So if you want to get really technical with it, going from decimal to percent is moving to the right. Going from percent to decimal is moving to the left. I try not to remember it like that because it should usually be fairly clear from what you're doing, if you at least understand the relationship between like percent and decimals. Like here's an example, 0.01. If you hypothetically couldn't remember what direction to move the decimal, in this case, you would just look at it and you would think, okay, so 0.01 is by definition 100th, because this is the 100th little category. Let's write 100th. So this is literally 100th. It's 1 out of 100. It's 1%. So even if you couldn't remember which direction to move the decimal, in this case, just using that basic logic, it makes sense just to move it once, twice to the right, and you get 1%. So usually I find it easier just to do stuff like that because I'm too lazy to memorize stuff, to be honest. But you know, it's up to you however you want to remember it. The next one is 0.777. So again, just move the decimal once, twice, and you get 77.7%. So a lot of people, for some reason, when they get this answer, they're like, oh no, it looks incorrect and I should keep moving the decimal. Don't keep moving the decimal. I realize I sound like a broken record, but it's only twice, Doesn't matter what the number is, just move it twice and you'll get the right answer. 77.7% in this case, it's a perfectly correct answer. It's the only correct answer.
One sec.
So 1.08, same thing once, twice, and that's 108%. Maybe we should skip a couple just because we're kind of running out of time. Okay, we'll do the next two and then we'll try to go through the next ones a little quickly. The next one's a really small number, 0.0042. So you should expect a pretty small percentage as well. So again, just take the decimal number or the decimal point, sorry, and move it once and move it twice. And it's just right there. So 0.42% is your answer. Again, it's reasonable because your original number was also a really small number. Last one is a really big number. It's 10.7522. So in this case, a lot of people panic and they're like, oh my God, it's 10. What the heck is going on? But again, the broken record tells you just move it over twice and that's it. Once, twice. In this case, you get a really big percentage. You get 1075.22%. Now, again, it makes sense because the original number was 10. It was a really, really big number. Keep in mind, 1 is 100% because 100% is just one whole. So in this case, getting a really large percent, it actually does make sense because the original number is super, super large. So just move it twice. What else? There is a chart that has some additional examples. I'm going to skip over that for now. Let's just leave it to everyone for practice. So it's 4 different examples. So everyone try that. And if anyone has any difficulties, just let me know. But let's try to do the last thing. So the last one is converting from fractions to percentages. And this is kind of a two-step method. There's actually 2 separate methods for it, but I'm going to present the first one and the easiest one right now. So let's say we have 3 over 100. With a lot of these, you can just pretty much automatically deduce the answer. 3 over 100 is, by definition, 3%, 3 per 100. So you can already anticipate that the answer is just going to be 3%. But let's get a bit more technical and a bit more formulaic. For these ones, the best way to do it is to use your calculator. First, take 3 over 100 and convert it to a decimal. So go 3 divided by 100. I finally fixed my calculator so that it'll actually show decimal numbers rather than fractions. So that's good at least. So 3 divided by 100 is 0.03. So at this point, all you've done is just converted it to not a percent, but just converted it to a decimal. And then the next step is convert it to a percent. So just move the decimal over twice. 1, 2, and that's 3%. So for converting fractions, this is usually the recommended method. Just use a calculator, convert the fraction to a decimal, and then take the decimal and convert it to a percent. So it's 2 steps. What else? 1 over 10, if you go on your calculator, it is 0.10. And then if you move the decimal over once, twice, you get 10%. Which makes sense because 1 over 10 is, it's the same thing as 10 over 100. So yeah, it's 10%. Last one is 3 over 20. Geez, this lesson is going by so fast. I didn't realize percentages were so enthralling. Okay, so 3 over 20, go in your calculator. 3 divided by 20 is 0.15. And then you just convert that to a percent, 15%. So there's a lot of mistakes that people do make in these cases. Let's go back to the first one just to illustrate some of the mistakes. Sometimes people will they'll properly convert it to a decimal, which is 0.03, but then they just leave it like that. And they forget that you're supposed to convert it to a percent. So remember to do that last step of properly converting it to a percent. Another thing that they'll do is they'll take the decimal number like this, and they'll just slap a percentage sign on it, and they'll totally forget to move the decimal over twice. So if you're going to slap a percentage sign on it, you got to move the decimal over twice. So there is a lot of mistakes that people can make with these, because I get a ton of these types of answers, when in reality, the answer should be 3%, not 0.03%. There is an alternate method for this one. I'm just going to get rid of this. One of the alternate methods, let's just look at an example. So first of all, the first method I think is the best method by far. The second method is what you can do is you could just straight up take your fraction and multiply it by 100. And the answer will automatically be percentage. So in this case, you multiply it by 100, and you can cancel out the 100 on the top and the 100 on the bottom, and you just get 8. And your answer is just 8%. But I don't usually recommend this method because sometimes it does require some more complicated cancellation or fraction manipulation. So I just recommend using a calculator, convert it to a decimal, and then convert it to a percent. I think that's the best way to do it. Let's do one more example. 5/8. Convert that to a percent. So go on your calculator, 5 divided by 8, it should be a little more than 1/2. It is, I think it's 0.625, but I'm not sure. Yes. Okay. And then of course, move the decimal over twice and you get 62.5%. And like I said, 5/8, it's a little more than half. 4/8 would be exactly half. So the answer you should be expecting should be a little more than 50%. I always try to anticipate the answer using some type of separate independent logic, just so I can confirm that my answer is correct. It's always good to do it that way. So we've run out of time. There's a couple of other examples, but not much else. And then there's some articles from quote mathisfun.com. Let's stop sharing. Today's only 1 hour, right? Yeah, and then tomorrow's 2, which again we'll just do it online. So let me just redo the attendance. And if anyone has any questions, please let me know. Let's see. We got this person, we got that, we got Drake, we got the other person, Jackson, we got him, James, Seth, and Tyler and Will. Okay, so we got everyone. Very good. And we got Buddy. He's still just chilling in my hood. So does anyone have any questions? Oh, just a reminder, assignment is due today, and then we'll take it up tomorrow. And then the second assignment is up as well. And I think we should just keep it simple. That'll be due next Wednesday, and then we'll take it up next Thursday. So same type of pattern. And I think we'll tentatively schedule the first test for Wednesday, October the 6th. And that'll be on both chapter 1 and chapter 2. So that'll be fractions, decimals, and percent. Seems like the easiest way to do it. Plus, I already have that test from another class, so it saves me time. Yeah, that's how we'll do it. So just everyone remember, get in the first assignment at least by tomorrow, because we'll be taking it up in the beginning of class. Any questions? Okay, everyone seems good.
So can we hand in our assignment today or tomorrow? The one that's due?
Yep,
Okay.
it's totally fine. And even if you hand in an initial copy, And if you want to hand in like an updated copy, that's fine as
Yeah.
well, as long as it's in by the due date.
Okay.
So I guess that's everything. So everyone, thank you for coming. And I will virtually see you tomorrow and have an
So we
awesome night.
have to hand it, the
Oh,
ultimate
go
due
ahead.
date is by tomorrow, right?
Yeah, by tomorrow. Yeah,
Okay.
by tomorrow, at least by the beginning of class. Yeah.
Okay.
So have a great day, everyone.
Okay, I hope you feel better soon.
Yeah, you too. Hope you feel better.
Thanks.
have a good day.
Don't worry, I'm good. I was just being safe.
Yeah.
Bye.